Automation revolutionized the way the Postal Service processes flat mail. Delivery point sequencing advances processing one step further, placing flat mail in the order of delivery. Thanks to a new program approved by the Board of Governors in December 2006 and new technology, delivery point sequence processing will be applied to flat mail. Known as the Flats Sequencing System, FSS program, this initiative enables the USPS to deploy sophisticated equipment to sort flat mail pieces in the same sequence as the delivery points on the letter carrier routes. Flat mail is one of the most challenging categories of mail to process, sort, and deliver due to variations in size, thickness, and address label placement. Flat mail pieces include large envelopes, catalogs, magazines, and newspapers. Currently, flat mail is sorted only to the zone or carrier level on our existing AFSM 100 fleet. This mail then must be sorted in a manual process into delivery order by the carrier before beginning deliveries for that day. FSS is designed to automatically sequence flat mail at a rate of approximately 16,500 pieces per hour. Scheduled to operate 17 hours a day, each machine will be capable of sequencing 280,500 pieces per day to more than 125,000 delivery addresses. Development, testing, and evaluation of a prototype FSS was conducted at the Indianapolis, Indiana Mail Processing Annex during the summer of 2006. A national deployment of 100 FSS production systems is scheduled to begin in late 2008. A pre-production system will be operational in the summer of 2007 in Dulles, Virginia. FSS consists of several subsystems that prepare, sort, and dispatch the mail, such as the production control system, the standalone mail prep, the dolly maker and dolly induct, the flats sorting machine, the tray staging device, the integrated tray converter, and caster cart. The Production Control System, or PCS, tracks and schedules mail volumes for processing using SV scan information and site-specific schedules. The Mail Prep subsystem accepts mail on pallets and rolling stock into the system and prepares it for automatic induction into the sorter. Flat mail bundles and containers are loaded into the Mail Prep subsystem by way of the Automated Bundle Separation Unit, or ABSU. USPS flat mail trays, FMTs, are inducted via the tray input conveyor. The bundle distribution conveyor transports the singulated bundles and FMTs from the ABSU to the mail prep stations. Here, the operator prepares the mail by removing the poly wrapping and strapping materials from the bundles and orients the flats and places them into automation-compatible trays, or ACTs. The ACTs enable automatic loading of the mail onto the flats sorter feeder ledge. Once filled, each ACT is conveyed to a dolly maker, which automatically stacks full ACTs on dollies. Fully loaded dollies are removed from the dolly maker and staged in the facility until they are ready to be sorted. Dollies of ACTs filled with prepared mail are transported from staging to the dolly induct docking station. The full ACTs are automatically removed from the dolly and inducted for first-pass sortation processing. ACTs are transported to the automatic induction, or AI-equipped feeders at each input line. The feeders on the input lines incorporate current technology, including automatic induction and automatic stack correction. The input lines singulate the flat mail pieces and transfer them to the optical character reader, barcode reader, and video encoding system. Here, an image of the mail piece will be lifted. The optical character recognition system incorporates a new generation of camera and optical character reader technology to resolve address and barcode information on each mail piece. Mail pieces that do not contain an 11-digit barcode receive an ID tag. The input line then injects the mail into a mini carousel, which is part of the flats sorting machine subsystem. From there, gravity drops the mail into a synchronized moving bucket attached to a carousel motorized chain on the sorter. The carousel moves the buckets into the sorter and discharges the mail pieces from the buckets into output trays. The blue output trays are called rigid captive trays, or RCTs, and are located on 2 levels and 2 sides of the sorter. Each mail piece is tracked as it travels through the input line and in the carousel bucket until it is discharged into an RCT at the appropriate sorter output bin. At that point, the mail pieces are associated with the RCTs and the system begins tracking the trays. During this first pass through the system, the mail for all carriers is sorted into stop groups. For example, all mail for all carriers' first stop is discharged to a single output location known as Stop Group 1. All mail for all carriers' second stop is discharged to another output location, Stop Group 2, and so on. During Pass 1, the automated tray handling system sweeps trays and sends them to the tray staging subsystem until the beginning of Pass 2. The tray handling subsystem manages the tray transport and staging between the 2 passes of operations and also processes the mail for dispatch. At the end of Pass 1 sorting, the RCTs move from the tray staging to the integrated tray converter. At the integrated tray converter, mail is transferred from the RCTs to ACTs for automatic induction into the sorter for Pass 2 processing. The ACTs created by the integrated tray converter are transported back to the feeders by Pass 1 stop groups. Mail is refed and sorted into walk sequence for each carrier. The system uses OCR and ID tag data for delivery address determination on Pass 2. During Pass 2, as trays fill up with sequenced mail, they are ejected from the machine and transported to the staging area once more. At the conclusion of Pass 2, the last trays from the sorter outputs are automatically sent to the staging area where they are sequenced with the stored trays and transported to the integrated tray converter. For Pass 2, the integrated tray converter transfers the carrier mail from the RCTs and places it vertically into street trays with the bindings to the right. A labeler prints and applies a human-readable dispatch label to the street tray. The integrated tray converter then automatically loads the labeled street trays containing sequenced mail onto a carrier-automated street tray rack cart or caster cart. Fully loaded caster carts are then removed from the FSS and loaded onto trucks for transport to the delivery unit. The FSS will provide the fastest, most efficient automated flat mail processing system in the world today and will give USPS mail carriers more time serving the customer and delivering the mail.